Hello, and thank you for joining me. In this video, I will walk through solving problem number 3, fact-checking HR. You can find this problem within the hard section of my practice problems at sqlshortreads.com. A direct link to the page can be found in the comments section of this video. Let's begin breaking this problem down by extracting key pieces of information from the prompt, exploring the tables required for solving the problem, and reviewing the expected output. Starting with the prompt, the Human Resource Department has recently made a claim that pay within each job is based strictly on the duration employed. Today you have been tasked with investigating the claim by creating a report with the necessary data to conclude the claim can be supported or disproved. Is this claim substantiated by the employee data? Assume that every employee has been in the same position since being hired. In your report, only include details related to those jobs held by at least 2 employees. Sort the result set by job ID ascending and employment duration descending. The method for determining whether the claim can be supported is up to you. Based on the prompt, we know the following about the requirements for the requested report. 1. Its purpose is to verify the Human Resource Department's claim. 2. Only those jobs held by at least 2 employees are of interest. 3. We can assume every employee has been in the same position since being hired. And 4. HR would like the report to be sorted in a specific way. Beyond that, it is largely up to us to determine the contents of the report and the strategy used for verifying the claim. In that statement lies perhaps the most difficult part of this problem. For whatever reason, this level of freedom can initially throw us off when preparing for interviews, or worse, during a live interview. For the purposes of this video, I will adhere to the tables required and expected output sections. That said, I'd love to see your alternative solutions in the comments section of this video. Alright, let us continue. Given the tables required section, we know we need 2 tables, the employees table and the jobs table. Both tables reside in the HR schema. Additionally, based on the expected output section, we know our report should contain the employee ID, employee name, job title, hire date, employment duration, and salary. The final 2 attributes, inconsistency flag and salary sequence descending, are those I have derived as part of my strategy for providing the necessary data to support or disprove the claim. I'll cover those shortly. Let's now dive into generating this report. Let's begin by recapping the key pieces of information we extracted from the prompt previously. I'm going to go ahead and paste those into the editor here so that we can easily see these and keep track of them. So the first key piece of information we extracted was that we only need to include the details related to those jobs held by at least 2 employees. I've also written an additional note here that for myself and for the viewers, this is a hint that I need some sort of filtering mechanism to ensure only employees corresponding to a job held by at least 2 employees are included in the report. The second key piece of information was that we can assume every employee has been in the same position since being hired. This will be useful when we're calculating the employment duration for each employee. The third piece of information we extracted from the prompt was that we need to sort the result sets by job ID ascending and employment duration descending. And I've noted that while this may seem cosmetic, sorting can make the consumption of data easier and allow an idea to be more effectively communicated. Let's begin solving this problem. So we know, based on the expected output, the attributes that we need, or the content that we need in our output. Let's review that quickly. So here's our expected output. We know we need the employee ID, employee name, job title, hire date, employment duration, salary, an attribute called inconsistency flag, and another one called salary sequence descending. What I'm going to do to just make this easier on us is I'm just going to copy and paste these headers into our editor so that we can address each of these one by one. What we need to do is we need to figure out where do each of these attributes reside. Are they pre-existing, meaning that they exist in one of the 2 required tables, so the employees table or the jobs table, or both? Maybe perhaps it's a foreign key, or it serves as a primary key in a particular table. Let's do that now. So let's explore the employees table and the jobs table within the HR schema. And if you don't want to write these queries, you can also do this on my practice problem homes page. I'll just show the case site here now. We go to the home page, I provide descriptions, and the entire contents of each table. So if we go to employees, the description reads as contains information related to each employee and a hierarchical employee-manager relationship. There is 1 row per employee. This is a key piece of information we need to understand for solving this problem. I also list out the primary key, which is the employee ID, the foreign keys that serve as primary keys in other tables. This allows us to understand the relationship between the employees table and other tables. And of course, the contents, right? So here are the contents of that table and all of the rows. We can page through those. Same thing with the jobs table, description stating that the jobs table contains information related to each job. It is possible for a job to exist without being assigned to any employee. There is 1 row per job. Again, this is critical. The granularity of this table is critical to being able to solve this problem. And here are the contents of that table. So in this table, we have the employee ID, first name, last name, email, phone number, hire date, job ID, salary, commission percentage, manager ID, and department ID. The jobs table is a little bit narrower. We just have the job ID, the job title, the minimum and maximum salary for that job. So what we're going to do here, we're going to take this knowledge and that we could have learned by writing these queries, right? We could have explored this in the editor here. We could have run both of these queries, or you can use my practice problems homepage, either way. But we're going to do it in the editor here so we can have it all in one view. So we have employee ID, employee name. So we know the employee ID based on our result sets from this statement here, select star from HR.employees. The employee ID resides in the employees table. So let's go ahead and begin constructing our initial select clause. Employee name. So there is not an attribute that already exists in the employees table called employee name, but what I can gather from this output is that employee name is the concatenation of the last name and the first name separated by a comma and a space. So what we can do here is we can do that. So let's do hr.employees.last name, and we'll concatenate that, and we'll separate it by a comma and a space. And I'm just going to call this employee name. And let's just go ahead and run this to make sure that this derived attribute employee name doesn't contain any syntactical errors. So king, comma, space, Stephen. That looks correct. So we have the employee name now. What else do we need? We need a job title. Within the employees table, we have a job ID. So this is going to be, according to the information I provide on the practice problems homepage, this is going to be a foreign key that is used for lookup purposes within the jobs table. So in the jobs table, we can look up each of those employee job ID values and find the corresponding job title, the min and max salary. So I know based on this, if I want the job title and I'm sourcing other attributes from the employees table, I need a join. So what I will do is I'll do an inner join, hr.jobs, and I'll say on hr.employees. .job ID equals hr.jobs.job ID. This is going to allow me to retrieve the information for each employee. So for each employee, I'm going to be able to gather the corresponding job information. So for example, if I go here and I go up to Stephen King in the first row, I'm going to take this job ID 80_pres. I'm going to use the join to be able to look up what the corresponding job title and min and max salary are if we need these attributes. Right now, we know we just need the job title. So what I'm going to do is I'm going to place the jobs title in the output. So let's do hr.jobs.job title. And we'll just run this again so that we can verify that this join is working correctly and then that we're getting the job title for each employee. And we are. So we now see the job title for each employee based on their job ID value. The hire date. The hire date, we know that's in the employees table. We can grab that. So let's do hr.employees.hire date. And I will just run this again so that we can iteratively see that this solution is actually still working as intended. So we have the hire date now for each employee. The employment duration. So if we go back to the table for employees, we have a hire date, which we can work with. And we also have this fact that we extracted from the prompt. That fact is that we can assume every employee has been in the same position since being hired. So if we want to calculate employment duration, and match this output, I can make sense of the employment duration outputs on this hard problem. Let's go to this page here, go back to my hard problem 3 and look at the expected output. If I look at this employment duration, it's pretty easy to infer that this is going to be in years. So this employee was hired on January 13th, 2001, and it's been 23.48 units since then. So I'm going to be able to infer that that is in years. So that's exactly what we'll do is we'll calculate the employment duration of each employee in years based on their hire date and today's date and time. So how are we going to do that? We're going to create a derived attribute that uses the months between function. And we're going to say months between sysdate, so a built-in function. And we're going to say between that date and the employee's hire date. And because we want this in years, right? This function is going to calculate the months between this end date and start date. If we want to convert that to years, we need to divide this by 12. So I will do that. I'm just going to go ahead and put this here. And then I'm going to say it is employment duration, because that's the specified column name in our expected output. All right, let's go ahead and run the code again to ensure that our calculation is working as intended. Before doing that, I'm going to go ahead and comment out this line and also just remove this down here at the bottom just so that I can use the shortcut control enter to run this query again. So let's run the query. All right, so we see our employment duration, it's working. So the number of years between June of 2002 and today's date and time is 22 and some change. What I'm going to do is I'm actually going to round this to 2 decimal places because most of the time the consumers of your reports and data aren't really going to be interested in this level of precision. It's not going to add any additional value. So what I'll do is I'll round this to 2 decimal places for each employee's employment duration by using the round function and specifying that I want to round to 2 decimal places by placing a comma after our calculation and providing the integer value of 2. So let's go ahead and run this again. So just double check, round, and what I need to do is I need to actually put 1 more parentheses here so that the round is operating on the result of this here. So the number of months computed between the sysdate, so today's date and time, and each employee's hire date divided by 12. So let's go ahead and run this. And now we see a much prettier output and employment duration value for each employee. So we have 2208, 2208 expected given the same hire date. The next step I want to take is let's continue working with this output here. So the expected output, what we're going to do is let's find out where salary is at. Salary sounds like it's going to be an attribute that's tied to each employee. So let's just verify that very quickly that it's actually in the employees table. And that we can just directly reference it because it's pre-existing. And it is. So the salary for each employee is going to be within the employees table within the HR schema. So I'm just going to go ahead and bolt that on here. Take that out. Let's run it again. And we see now that we have the salary. With that, the output now includes all of the pre-existing and derived attributes aside from inconsistency flag and salary sequence ascending. Remember, those 2 derived attributes are responsible for providing the necessary data to support or reject a charged claim. I'm going to put a hold on those for a moment while we knock out 2 other minor requirements that are a little bit easier to walk through. The first one we're going to knock out here is the sorting. So how can I sort the result sets or this report based on job ID ascending and employment duration ascending? That's quite straightforward. What we're going to do, or I'm going to do, is I'm going to put a order by clause. And I'm going to sort by hr.employees.jobid, and then employment duration, and descending order. And I've executed the query, it runs successfully, so our result set is now sorted by job ID and the employment duration in descending order. So we've knocked out this minor requirement from the prompt. Now we need to address this here. So the filtering mechanism responsible for ensuring employees corresponding to a job held by at least 2 employees are included in the report. So we only want to include those types of jobs. We don't want to include jobs and corresponding employees where only 1 employee holds a particular job. So how can we do this? Typically, in other scenarios, what you're going to do is you're going to use a having clause directly within the query and say, for example, in this case, if we want at least 2 employees, we can say having count something. So let's say count employee ID greater than or equal to 2, or just technically we could just say greater than 1, right? But sometimes you're going to have queries where fitting in an aggregate and a having clause, it's a little bit more difficult, right? You don't want to use your traditional filtering mechanism because it's going to muddy up your query. In that case, if we did do a having clause here, we would need the group by, right? So we would need the group by, we need to be grouping records, we would need that aggregate, right? We would need an aggregate function. We would need to aggregate something, and as a result of doing that, we would need to perform or add any non-aggregate attributes or any non-aggregate functions into the group by clause. And we don't really want to change the level of detail of this output, right? We want 1 row per employee. And I also don't want my query to just look like, oh, we have a bunch of, min employee ID, min this, just for the sake of satisfying the SQL engine's requirements. So what I'm going to do is I'm going to use a common table expression. And the filtering mechanism we're going to implement is using a common table expression to return the list of job IDs and job titles corresponding to those jobs that have at least 2 employees. And we're going to perform a join between the common table expression and the final select clause or select statement that is going to allow us to naturally filter to only those jobs where there's at least 2 employees tied to them. So let's walk through that now. So I'm going to say with applicable job as, what I can do is I can say select hr.employees.job ID hr.jobs.job title. So if you remember correctly, the job title is in the jobs table. We're going to use the job ID in the employees table to look up the corresponding job title in the jobs table. So I'm going to say employees, enter join, hr.jobs.jobs, and we're going to join on the job ID attributes. That's the shared attribute between these 2 tables. The relationship is that each employee is tied to exactly 1 job. Let's go ahead and run this really quick. And this query is not going to give us the expected granularity. This is not the granularity we need for this common table expression. We need this to be 1 row per job ID per job title. So what we're going to do here is we're going to say group by and group it by these 2 attributes. And the reason this result set returns 107 rows is because there's 107 employees. We've joined between employees and jobs. And the relationship between that is there's 1. So each employee is tied to exactly 1 job or has 1 job. And a job may be held by 0 or more employees. So that's why we're getting 107, right? We're not getting this. This is not a 1-to-1 relationship between employees and jobs. There's not for every job in the jobs table, there's not just 1 employee. So again, let's just go ahead and run this. And we're going to see that we're going to get 1 row per unique job. There's 19 jobs. But how many of those jobs have at least 2 employees tied to them? Well, we can figure that out by saying having count hr.employees.employee. I can say employee ID, right? So let's just say employee ID is greater than 1. This is going to allow us to filter to a smaller result set here. So we shouldn't see 19 because I know for a fact that it's not every job has at least 2 employees tied to it. We're going to be able to achieve or fulfill this requirement of only including details related to those jobs held by at least 2 employees. So let's run this. And what do we get? We get 9 jobs. So if we have these 9 jobs, what can we do with this result set, this intermediate result set? We can use this and perform a join here in this select statement, an inner join, which is going to act as a filtering mechanism, right? So for every job ID in this intermediate result set, so applicable job, go and find the corresponding employees that have one of these job IDs. Otherwise, filter it out. Don't include it in the result set. So let's do that. And how are we going to do that? So what we're going to have to do is we're going to have to augment this query here. So I'm going to take this, instead of saying I want to reference jobs, I'm going to say applicable job because I want to reference the CTE. And I'm just going to do some copying and pasting here. So applicable job, anything where we reference an attribute from the jobs table, I'm going to replace that with the output of our common table expression. So the job title, I'm going to get that from there too. What else? I don't believe there's anything else. Let's go ahead and run this to make sure this works. It does. Now what we're going to see here, instead of 107 rows, right? So previously we saw 107 rows, one per employee. We're only going to see those rows where the employee is associated with a job that is tied to at least 2 employees. So if we scroll all the way down here, we should have less than 107 rows, and we do. We have 97 rows. So 97 employees hold the job with at least one other employee. Moving on to perhaps the most critical part of this report is identifying those instances where HR's claim doesn't hold up, if there are any. Remember, HR's claim is that pay within each job is based strictly on duration employed. Now, how might we investigate that manually? Well, we could, let's just say, filter to a subset of the employees, say a particular job, employees holding the same job. Let's just say programmers, for example. If we look at these programmers, so all of these employees hold the same job, they are programmers, and considering that we've sorted this result set by employment duration descending, if HR's claim is true, then David should be the highest earning programmer because he's represented in the result set first, because we sorted by employment duration. So he's been at the company as a programmer the longest. But we see quickly that that's not true. David makes $4,800 and Alexander makes $9,000. Furthermore, we see that David, Valley, and Diana all make less than Bruce, who is the most recently hired programmer. So we know right off the bat that there are instances where HR's claim does not hold true. What we want to do is we want to implement a strategy that's going to allow us to identify these programmatically. No one's going to have time to go through a list of 107 employees or thousands of employees in a real-world scenario and manually identify these instances. Again, we need a programmatic approach for this. So how might we do this? We need to implement a strategy that's going to allow us to set aside each group of employees based on job title and programmatically identify where the current row's salary value is less than or equal to the next row's salary value. Well, that sounds like a job for a row reference function. So something like lead or lag, a particular type of window or analytic function. Let's look at how we might do that just using this subset of employees, these programmers, and then we'll apply this to the entire employees listing. So we'll put these at the very end just to match the expected output. So I'm going to call this the inconsistency flag. So if you see here, the inconsistency flag is populated with ones and zeros. And what you'll learn here in a moment is that is indicative of true and false. So is there inconsistencies with HR's claim or is there not based on the current row? So let's go ahead and begin with that attribute. Again, if we want to look, compare the current row to the next row, we're going to use a row reference function. So in this case, lead. What we can do is we can say case when lead, and what attributes are we going to be using? What are we trying to observe or compare the current row to the following row? Well, we want to look at the salary, right? So we want to look at the employee's salary. Just what I'm trying to do here is to take that manual approach we did here, just eyeballing things, and implement a programmatic strategy, right? Something that we can do programmatically as opposed to this manual operation. So I'm going to say HR employees.salary. And I just want to look at the next row, right? So I'm going to say 1. So look at the next row. So case when, the next row's salary value. And the default value, I'm just going to put the current row just in case there isn't the next row. Let's say over. And over what? So we want to say over and then partition by hr.employees.jobid. If you're familiar with window functions and you already know what this does, but I'm just going to reiterate what this is doing here. This is going to allow us to take each subset of employees based on job title and perform this analytical function, right? Because I don't want to compare a programmer's salary to an accountant's salary, even if it is the next row, right? So for example, if this row, the second row here, belonged to an accountant, I don't want to make that comparison. I don't want to make that logical, that check. I only want to make the check, look at the next row, if the next row is indeed a programmer, right? The current row has the same job title as the following row. So in order to do that, we're going to set aside those subsets of employee records, or these rows, based on job title, group those together, perform the operation, and then bring it all back together as one entire result set. So partition by hr.employees.jobid, and then I want to order these partitions by the employee's hire date and the employee's salary in descending. And why am I doing this? Well, I'm doing it because this is how we're building in our inconsistency check, right? So if I sort these rows based on the employee's hire date and the employee salary, well, again, the first person hired should have the highest salary. And the highest salary, so we're going to find the highest salary because we sorted it in descending order. That means technically what we would ideally want, or HR would want to support their claim, is they'd want Alexander to have been hired first. They would have wanted Bruce to have been hired second. And then either David or Vali hired third, and then Diana hired last. But we know that's not the case, but that's what I'm just walking you through, why the order by clause is constructed in such a way here for this window function. All right, so what are we going to compare this to? So what are we comparing the following row or subsequent row to? We're comparing it to the current row. So I'm just going to reference the current row's salary. So again, what this is saying is case when, so we're setting up a condition that says when the following row, so this reads as the following row with respect to the job ID, right? So we only want to compare the current row to the following row if they have the same job title. And that's really not something that type of check's not actually being done really, because we're partitioning by that. So that's a guarantee. We're gonna take that following row and compare it to the current row's employee salary. And if it's less than or equal to the current row, then we're gonna say 1, so true. Else 0. So when it's 0, so false, that means, well, HR's claim is holding up. The employee that was hired earlier on is making more than the employee that was hired later on or more recently. I'm going to say case end, and then I'm going to say as inconsistency flag. So let's go ahead and run this. And I'm just going to do this with the programmer still. And you'll notice that we immediately identify, so these are the things we identified earlier on, right? We identified inconsistencies in HR's claim. So this is an inconsistency because this employee makes more than David, even though he was hired on after David. This is an inconsistency, and this is an inconsistency. So this value here is not less than or equal to the following row's value. This value here is not less than or equal to. This value is. And now we've successfully identified all the inconsistencies in HR's claims, right? But the average person that's reading this report might not really like the idea of an inconsistency flag, or they may not understand it, or it may not be intuitive. What we can do to make this intuitive is we can add the result of a window function, so dense rank. So we can take dense rank, and I'll just do that now and explain it here in a moment. I'm going to compute a dense rank over the same partition, so by job ID. And I'm going to order it by just salary. in descending order. And I'm going to call this, again, just to match the expected output, I'm going to say salary sequence descending. When I run this, we're going to easily see the value that adding this salary sequence descending attribute adds to our output. For some of the consumers of our report, they're going to find that making sense of this inconsistency flag, which is going to identify those instances where HR's claim holds up or doesn't hold up, a lot easier to understand. So this is all about conveying this idea effectively, or as effective as we can. Let's go ahead and run this. You'll see that the salary sequence descending attribute contains a series of integer values, right? So we're expecting that, right? We understand the dense rank function. We understand that we've partitioned it by the job ID value so that we're able to subset this data based on job ID value. So take the employees that are programmers, set them aside, compute the dense rank across those programmers, those rows associated with programmers based on the instructions of ordering the rows by salaries in descending order, and then putting it back together with all the other employees, right? Because we're going to ultimately return the entire list of employees that meet the criteria of this prompt, regardless of their job title. Now, what do these values mean? So if we've partitioned by job ID, and in this subset, we're looking at just programmers, or this output, we're looking at just programmers, and we've sorted by salaries in descending order, and we've already sorted this result set based on job ID and employment duration, that means that we should see if HR's claim holds up consistently and across the board, we should see the integer values assigned to each of these rows in sequential order. So we should see a 1, a 2, a 3, a 4, and a 5, but we don't. We see a 3, a 1, 3, 4, and 2. This is stating that, hey, David, although hired first and represented in the first row, David has the third highest salary. So why does David make less than employees hired later on? Same thing with Alexander. Alexander is represented in the second row and was hired second amongst programmers, yet he has the highest salary. Diana was hired fourth and has the fourth highest salary. Bruce was hired last, or most recently among programmers, yet he has the second highest salary. So he makes more than several other programmers that were hired a year or two before him. So this attribute is going to allow the consumer of the report to more easily, so maybe if they don't understand it by inconsistency flag alone, they're going to be able to put the power of these two attributes together to understand, okay, where is the claim not holding up, or where is it holding up? What I'm going to do is, just to meet the requirements of the entire prompt in this problem, I'm going to remove this where clause, because we don't want just programmers, right? We want all of the employees holding a job that's associated with more than one employee. And that's the solution. So we're able to see where HR's claim can be supported or rejected across all employees holding a job that's associated with at least 2 employees. Now, I just want to remind you that this problem was a little bit different, right, than your average practice problem or interview prep problem, and that it required you to come up with the method for determining whether the claim can be supported or rejected. And I think that's where the difficulty is. The difficulty is when we're given this type of freedom, we don't know what to do with it. It's unexpected. Usually we're explicitly told, hey, do X, Y, Z, and that's it. And it's easy, right? We're being told what to do. But here we have to think about how we might go about doing something in our own particular way. And there's a lot of ways to solve this problem. I look forward to actually seeing what you come up with when trying to solve this problem. Please feel free to post your solutions in the comments section of this YouTube video. I'd really like to see them. I think that there are a lot of talented people out there, and I think a lot of creative people, right? So I think you might even be able to come up with a solution that makes more sense than mine, right? Or is more optimal, or just more straightforward, like intuitive, I suppose. This solution, whenever I was writing this problem, it just kind of came naturally to me. I knew that I could use a row reference or window function to compare the current row salary value with the subsequent row. So take the employee salary that's captured in the current row and compare it to the subsequent employee that has the same job and see, hey, do they make less than or equal to an employee that was hired later than them? And if so, well, that's an inconsistency, right? That's where the claim can be rejected. If not, then the claim can be supported. If you enjoyed this video, then please like the video and subscribe to my channel for notifications on future videos. Thank you again, and see you next time.